Hello children, in today's chemistry class, we will discuss our next chapter, chapter number 2, acid, base and salts. Our first topic is acid. Let us understand what is acid. Our first point, these are sour in taste. Our next point, they turn blue litmus to red. See, I am having blue litmus paper and apple cider vinegar. As you know, vinegar is acid in nature. If I am see, it turns blue litmus paper to red. And next, they give H plus ion in aqueous solution. Means if we dissolve acid in aqueous, means water solution, it gives H plus ion. Acids are dissociate and it gives H plus ion. Next, acid corrode metals. Means if metal is contact in an acid, it corrode itself. Now, for example, there are two kinds of acids, strong acid and weak acid. For example, strong acids, hydrochloric acid, HCl, sulfuric acid, H2SO4, and weak acid, acetic acid, oxalic acid and citric acid. We know that lemon is acidic in nature, and in lemon citric acid is present. Now come to the next, concentrated acid. What is concentrated acid? Means those acid which are pure or higher concentration in water, they are called concentrated acid, or in a easier way means higher quantity of acid then plus lower quantity of water, very less amount of water. So these are called concentrated acid, and same opposite to the concentrated dilute acid or diluted acid means those acid which are not pure or very low amount of very low concentration in water, or in second way, higher quantity of water means water quantity is more as compared to acid quantity. And let us to understand in this way, if we add in a concentrated acid water, we get diluted acid. Means if we increase the water percentage in concentrated acid, water percentage in concentrated acid, we get diluted acid. Clear? Now come to our next topic. Our next topic is bases. What are bases? These are bitter in taste. They turn red litmus to blue. Let us to see. I am having red litmus paper and soap water. As we all are know that in soap NaOH means sodium hydroxide is present, and sodium hydroxide means NaOH is basic in nature. If I dissolve red litmus paper into soap water, it's turns blue in color. Means bases are turned red litmus paper to blue. Clear? Next, they give OH minus ions, mean hydroxyl ion in aqueous solution, in water solution. Means if we dissolve bases in aqueous solution, means in water solution, it dissociate and it gives OH, means hydroxyl ions. Next, soapy in touch. If we touch bases, it's look like soft, means soapy. For example, there in bases also there are two kinds of bases, strong and weak. First, strong bases, sodium hydroxide NaOH, KOH potassium hydroxide, CaOH whole twice, calcium hydroxide. And weak bases, NH4OH means ammonium hydroxide. And next one is alkali. What is alkali? These are also bases. These are bases which are soluble in water. For example, NaOH is soluble in water, so NaOH is alkali. Clear? Now children, come to our next topic. Our next topic is indicators. What is indicators? These are the substance which change their color or smell in different type of substance. Means to identify which is acid or which is base, we use indicators. Indicators are helping us to identify which is acid or which is base by their color, smell or odor. Now come to the next types of indicators. There are different types of indicators. First type of indicator is natural indicators. Natural indicators, those indicators found in nature in plant called natural indicators. Means those are already present in nature. They are called natural indicators. First example is litmus paper. Litmus papers are also made by plants. We already saw that acids are turned blue litmus paper into red and bases are turned red litmus paper into blue. And next example is turmeric. Turmeric is also a example of natural indicator. Turmeric are how do we identify? By using turmeric which is acid or which is base. So in acid, turmeric is in nature yellow in color, and if we add acid in turmeric, there is no change, means its color is yellow as well. And bases, if we add bases in turmeric, so it turns yellow to red. Let us to see. This is turmeric and its color is naturally yellow. If I am adding acid, I am again using vinegar. Again I am using vinegar, and if I am adding vinegar in turmeric, its color is not change. It is yellow in color. And now check base also. Again I am having it turmeric solution in distilled water solution. Now I am adding NaOH, means again I am using soap water, and soap, in soap water sodium hydroxide means NaOH is present. If I am dissolving soap water in turmeric, it turns into yellow into red. So turmeric is also a natural indicator, and it is help us to identify which is acid and which is base. If we dissolve, if we add acid in turmeric, there is no change, and if we are adding base in turmeric, it turns yellow to red. Clear? Now next type of indicator is synthetic indicators. These are chemical substance and these are prepared in laboratories. For example, methylene orange. Methylene orange is dark red in color. When we are reacting with base, methylene orange turn into yellow color, dark red to yellow. And if we are adding methylene orange into acid, it turns dark red to red. Let us to see. Methylene orange, if we are adding in acid, it turns dark red to red. If we are adding methylene orange in base, it turns dark red to yellow in color. Clear? Now next example is phenolphthalein. Phenolphthalein is colorless solution. If we are adding phenolphthalein in basic solution, we get colorless solution to no change, means in this solution there is no change. If we are adding phenolphthalein in acidic solution, the colorless solution, it turn into pink color. See, if we are adding phenolphthalein in basic solution, there is no change, it is colorless. But if we are adding phenolphthalein in acidic solution, it turns light pink color. Clear? Next, olfactory indicator. It is most important topic. These substances have different odor, means smell in acids and base. They are showing their odor or smell with acids and base. First example is vanilla essence. Vanilla essence is used in ice cream factory for flavor. As we know that vanilla essence is used in ice cream factory for flavors. Vanilla essence, if we are reacting or if we are adding vanilla essence in acid, when vanilla essence comes in contact with acid, its smell get increased, and when it comes in contact with base, there is no smell come out of it. Clear? Next example of olfactory indicator is clove oil. When clove oil comes in contact with acid, its smell get increased, and when it comes in contact with the base, its smell get decreased. Clear?